Hi, Year 11. So this video is the last in the binomial theorem topic, and it's looking at 15e, and it's about using the general term. Now, we've had a look at the general term earlier on in a few exercises beforehand, and it says the general term is an expression for any element of the expansion written in terms of R, so that any substitution to the expression will yield or give us a particular term of the expansion. But before we go ahead and look at that general term, I just want to move over to the side here and have a look at some ways we can write the general term. So if we were looking at expanding a plus x to the n, we could write the general term in terms of k or r. We could see it both ways. So the r plus 1 term, or the r plus 1th term, is written as NCR a, which is our a here, to the n minus r x to the r, noting that this is r plus 1. So our value for r here is going to be 1 less than what we've got here as our term number. And that has to do with the fact that when we're expanding, we would have NC0 would be our first coefficient and NC1 would be our second. So we're starting at 0, so we're always 1 up in terms of our term number. You might see it written like this. Instead of r, you might see a k. And we're noting that our NCR in our brackets can also be written like this, as NCR or NCK. In this case, instead of an X, we've got a B in our expansion. So just noting that there are different ways we can write it, and either of them are okay. So I thought I'd go over and do a little bit of revision to start with. And over here, I've got the question, and it's asking us to find the 6th term of this expansion here, 2x plus 3y to the 9. You may remember how to do that. We'd be looking at term 6, and that would be looking like NCR a to the n minus r, b to the r. So if we've got term 6, we've got 9 as our power, because we have a 9 up here, NC5. Because if we look at our formula, we're looking at term k plus 1, and here we have 1 less than that k plus 1, which is k. So we want term 6, we'll have a 5 down here. Our A relates to our 2x, which is our first part of our bracket to expand. We've got n minus r, or n minus k. I'm going to pop that in as an r, that should be, sorry. So n minus r, which would be 9 minus 5, which would be 4. And then we've got our 3y in our second part of the brackets, which is 5. And our 5 and our 4 must add to 9. So the 6th term would be 9c5. We're going to have 2 to the 4, x to the 4, 3 to the 5, y to the 5. Now we're going to need to pop that in our calculator. So 9 choose 5 is 126. 2 to the 4 is 16. 3 to the 5 is 243. The x to the 4 and the y to the 5, I've just popped on the end there. So let's neaten that up. And we're going to have an x to the 4y to the power of 5 on the end. And that would be our 6th term in that expansion, which is a really enormous number. We could do heaps of those, but I want to look at some more difficult ones, okay, because we are extension 1. So what I want to have a look at is finding the general term in the expansion in your booklet of 2x squared minus x to the minus 1 to the power of 20. Noticing that x to the minus 1 is 1 over x. So we're going to end up with cancellations along the way. And then we're going to use this to solve to find the term for x to the power of 34 and x to the minus 5. So noting that our term k plus 1 of an expansion that is, say for example, a plus b to the n would be, oops, hang on, I forgot my NCR, sorry, which would be, make that an n, NCR a to the n minus r, b to the r. That might be something, and I know I have to often look at it just to get familiar with it, over there on the right. And as we get further on in our formula sheet, there is a formula in another section that may help us a little bit out with that, but we're not going to look at that one now. So we're looking for the general term of that expansion. So let's see what we've got. So we're going to have term n plus 1 is going to be, I might leave out the n plus 1 and just write it generically, which would be 20 CR, and we're going to have our a there, a down here to the n minus r, relates to this 2x squared. So we're going to have 2x squared in our brackets. And we're going to have 20 minus r. And then we're going to have minus x to the minus 1. So note that that minus needs to go in there. And that makes our series interchange between positives and negatives. So we can't leave that one out. And our other power here is going to be r. Okay, now, yes, that's the answer. I don't want to write it like that. I want to neaten it up. We know we always want to try and make things neater, and we've learnt that in our advanced course that we need to make things neater so that when we're looking at things like multiple choice or getting answers into a different format, we know what we're doing. So I'm going to split the 2 and the x squared up and make those both with the power of 20 minus r. So we're going to have 2 to the 20 minus r, x squared to the 20 minus r. I've got this minus 1x to the minus 1 over here, which is really minus 1 to the r. So I'm going to split that up as well and make it minus 1 to the r, and I'm going to have x to the minus 1 to the r. So what that's going to give me, again, is 20cr. I've still got my 2 to the 20 minus r. I'm going to expand this 2 out in my brackets, remembering what our rules tell us. So we're going to have x to the 40 minus 2r. I've still got this minus 1 to the n, and now I've got x to the minus r. But we can go one step further. Okay, so if I neaten that up, and I can still write my 2 to the 20 minus r, and I've still got my minus 1 to the n. Here I've got a base of x and another base of x, and I've got 40 minus 2r, and I've got another x minus r. So when we're multiplying things with the same base, we add our powers. So it's going to be x to the 40 minus 3r. And that is a suitable answer. It's in our most simplest form that we can get that into. Okay, so what we're going to do now is we are going to work out our part A, the term for x to the power of 34. So now that we have our general term over here, what we can do is we can apply this power of 34 with our x to this 40 minus 3r. This is only wanting us to find the term that belongs to this x to the 34. But in order to do that, we need to know what r we're talking about. So we're going to basically be equating coefficients and be letting our 34 be equal to 40 minus 3r. So in solving that, do as you please in solving that, but I'm going to take 40 from both sides, and I'm going to end up with 6 is equal to, minus 6 is going to be equal to minus 3r. So 2 is going to be equal to r. So now I've got my r, I'm going to apply that to my general form above. So it's going to be 20c2, 2 to the 20 minus 2, minus 1 to the 2, x to the 40 minus 3 times 2, which is 6. So that's going to give us 20c2, 2 to the 18, minus 1 to the power of 2, and x to the 34, which is what we wanted. So let's pop that in our calculator. What's 20c2? I'm going to end up with 20c2 is going to give us 190. So it's going to be 190 times 2 to the 18 minus 1 squared is going to be 1, x to the 34. And let's pop that in our calculator again. There's an enormous number of 49,807,360, x to the power of 34. So I guess a nice tip in these questions is you're going to get some strange looking coefficients. Just double check you're working, but know that maybe you're correct with those ones. We want to find the term for x to the minus 5. So similar to what we did before, we need to equate coefficients like we did above. We want to have 40 minus 3r to be equal to minus 5. Minus 5 plus 40, we're going to add 40 to both sides. We're going to end up with 35 is going to be equal to minus 3r, as that was a very silly mistake on my behalf. I'm going to be taking 40 from both sides, not adding it. Minus 45 is going to equal to minus 3r. That looks better. 15 is going to be equal to r in this case. Okay, so let's just apply that to our generic formula above. So we've got 20 C15 2 to the 20 minus 15 minus 1 to the 15 x to the 40 minus 45. That's going to give us, oops, neatening that up, 20C15, which will pop in our calculator in a minute, 2 to the 5 minus 1 to the 15. Because 15 is an odd power, we're going to end up with a minus in there, so I might just pop that out the front now. We're going to have x to the minus 5. So 2015, let's pop that one in. I'm going to end up with 15,504. I'm going to times that by 2 to the 5. We're going to have x to the minus 5. I'm going to end up with minus 496,128 x to the minus 5, which is what we would expect. We had a negative up here, so we're going to be alternating between positives and negatives. We worked out that when we had a positive power, we had a positive number, not a positive power. When we had an even power, we had a positive number. When we had an odd power, we had a negative number. So that looks about right.